Hello and welcome to the Ultimate Liquid Turbine Meter webinar. My name is Hannah DeYoung and I am the Marketing and Communications Manager at Daniel. I'm very excited for this webinar. We will be covering the product's history, the applications, the features and benefits by our very own Angela Floyd. Now, before we get started, a few housekeeping items. Your mic will be muted for the duration of the webinar. We will have a Q&A at the end of the webinar, but please feel free to submit your questions at any time during the webinar into either the chat box or into the Q&A panel. We also have a few mystery prizes to give away. At the end of the webinar, I will send out a survey, and once you complete the survey, you will be automatically entered to win a mystery prize. If you would also like a copy of the presentation, by completing the survey, you will receive a copy automatically. A quick bio about Angela Floyd, product manager at Daniel. Angela was originally at Daniel Industries in Scotland before moving to Houston to support the liquid turbine meters and the development of the original Daniel ultrasonic meter. She comes from a mechanical engineering background with over 30 years experience in this industry. She has applied her knowledge to field applications in the gas and liquid pipeline community and in the upstream and offshore industry. She has written and contributed to over 28 technical papers while serving on research committees. All right, Angela, take it away.
Hey, good afternoon, everyone. So glad you joined me today. So as Hannah said, yeah, I did join Daniel Bay back in Scotland in 1988, actually, working in the systems group, and then finally moved to Houston to work on turbine meters. So I've been working with these beauties for a long time, and hopefully I can provide you some information and maybe some update on where Daniel is with the turbine meter brand. So some of the things I want to discuss today are the reliability, integrity of this product. You know, it's been around for a long time. People have used it, people have relied on it, and it has kind of stood the test of time, keeping uncertainties and improving in quality and reliability over the years. We'll also talk about the rangeability, and by that I mean this meter is available in a whole range of sizes and several designs, and it also covers a full range of flow rates. So we'll cover some of that too in this. Performance-wise, as many of you know, the turbometer is considered the most repeatable meter in the market. It's used for calibration of all other types of meters. So we'll look into some of the rangeability, linearity, uncertainty, and repeatability of the products. And of course, the versatility, where can we use this meter? You know, in small line sizes, large line sizes, and we'll look at some of the applications that this meter has been used in over the years and continues to be used. So a little history of the turbine meter. Apparently in the 1900s, it was being used in aviation and fuel loading. So with that and the development of jet and rocket engines, there was a need for more accurate and more real-time measurement of the movement and consumption of fuel in aviation. So in 1965, Daniel purchased the rights of the PT meter from Potter Aeronautical. So the whole manufacturing and design came then. In 1970, API, which as you probably know, kind of sets the standard for most metering and acceptance of metering equipment. So API 2534 was developed and lasted for a long time before it was updated to be included in the API 5 chapter. So it's API 5.3, a very strong relation to API 2534. There hasn't been many changes, but there has been some updates, so you should get a hold of that one. In 1991, I came to Houston and joined the Daniel team working on the liquid turbine meter. And I was lucky enough to work with a man called Bernie Geisau, who actually came from Potter back in 1965. So he was a remarkable man and kept all his notes on graph notebooks, and was always willing to share and tell you how excited he was about whatever new design he was working on. So he's actually responsible for the suspension system we use in our 1500 series today. Thank you. So we didn't stand still from 1965 or 1970. We did move along. We had a whole range of meters back in the 1990s. We had our Daniel PT type meter and the LR type meter. We also combined with Brooks to get the UMB and the parity style meters. And along the way, we took what we felt was the best of both sets of meters and combined it into where we sit today. So we have two versions of the meter. We have the 1500 turbine meter and also the 1200, which is the one you see here today. So the 1500 was basically designed for pipeline applications, working continuously, given reading across the range of pipeline, fuel, uncertainties, custody transfer type uncertainties. So this meter was designed to be the kind of workhorse of the liquid measurement. The 1200 series was developed to meet the loading rack type applications, so truck loading. It was only available in smaller sizes, and again, it's a different design than our PT type meter, but we'll get into some of that as coming up. So the 1200 meter is the one you see sitting here today. I don't know if we can turn it around. Can we get a little rotation going? Yeah, I'll just get it around to the front. So I hope you can see a little bit of it with flow conditioner and cantilever design. As I said previously, it was used for batch operation, low viscosity type applications, so not your high viscous flows. It was a low cost, and it fit very well in that batch loading application. Now the 1500 series, as I said, was designed for pipelines, ship loading, continuous operation, and could get up to some mid-level viscosities. It was also low cost relative to other types of metering out there. It was used for light crude and refined products. It was also available in bidirectional design, and this is how it looks right now. And it was designed rugged and simple in order to meet those requirements while providing the best performance. So as I said, that the 1200 series, this meter was only available in the smaller sizes, 1 inch through 4 inch, but it did cover up to 785 barrels per hour. In the smaller line sizes, we could still get premium linearity of 0.15% with repeatability 0.02, and then went up to 3 and 4 inch line sizes, which is probably where you would see it on loading rack and batch loading applications. It is available in ANSI 150 and ANSI 300s. Now the 1500 went all the way up to 24 inch, and it covered ranges up to, and I can't see it because I have to move this little thing here. It went up to 69,000 barrels per hour. As I said, available in 1 inch through 24 inch, all the way up to 2500 ANSI ratings. So again, covering a full range of applications that was probably unseen of at the time back in the 60s with one particular technology. We did get our 0.15 premium linearity as standard, and we were also able to meet a 0.07% uncertainty, but that was over a limited rangeability. So again, these 2 meters cover a full variety of applications with similar technology. So the 1200 meter was a cantilever design. I think you can see a little bit of it here. You'll see that it was it's a blade type meter. The internals are mainly stainless steel or aluminum. We have a lightweight rotor, and basically it's been the same design. It was brought in from the LR, the old LR type meter. It does have a flow conditioner, in particular designed to work in replacement of a PD type meter. So the face-to-face length was based on some of the PD design, and you should be able to replace it directly into the an application like that. You did not require upstream lens, hence the flow conditioner was able to provide you with a fully developed flow. So that's one of the benefits of this smaller meter, because as you probably know, API 5.3 requires upstream lengths, 10 diameters, flow conditioners. With this type of meter, it's not necessary. The 1500 meter is available in a blade type and a rim type. So we can see from this particular design some of the differences between the blade and the rim. And you can also see that this is balanced on both sides. So it's suspended between the up and downstream. The rotor is suspended between the up and downstream hangers, those hangers that Bernie Geisau designed so many years ago. So the rotor itself has less blades, but it's a much more rugged design. It also has several buttons embedded in the rim, and that allows you for a higher resolution pulse output. Another difference between the 1200 and the 1500 series. Nevertheless, both are easily calibrated based on small volume provers, ball provers. Both meet the requirements of API 5.3. So what happens when you get a pulse output from these meters? So as the rotor rotates, it creates a flux between the pulse, the button or the blade, and a pickup coil that's embedded in this meter design. So that in this particular design, we have taken the two outputs that are normally you see 90 degrees physically apart. We have combined them into this single outlet box that provides 90 degrees electrical, two pickup coils in a single outlet. So in this box, we have a single preamplifier with a dual channel output. So that's something that's pretty unique about the Daniel meter. But in order to get a pulse output and get it amplified, you have to have something on top of the meter to transmit the signal to a flow computer wherever you're putting it. So we have many options available in that for that purpose. We have the dual channel preamplifier, like I said, fits directly in here. But you can also fit two preamplifiers in here if you need two independent outputs. We have an intrinsically safe model. We have a zero crossing, which allows us even more pulse output, so higher resolution. And as I said before, the Daniel meter is available in bidirectional, working both ways. And what that does allows us to use these particular cone designs. I'm sure these were Bernie Geisau designs too, upstream and downstream cone designs, which allows that rotor to balance in between. If it's a bidirectional, we use two upstream cones, so the rotor will flow in both directions. So those are our four preamplifiers available for signal output. If you want a local readout, we have our little our little XRT totalizer. This is more than just a totalizer. You know, it is lots of storage space, can totalize, can provide flow range total. You can linearize your curve in this totalizer. So if you want higher resolution or higher accuracy over a particular flow rate or range, this linearization function will help you do that. You can also have direct pulse output. You can have 4020 analog outputs, and you can hook up Modbus and program remotely. So it's very, very handy little totalizer that can sit directly on the meter or off the meter if you want to include preamplifiers with it and with the totalizer. So both options are available, or a combination of each is available for use. So where are these meters used? I think you've probably seen them in most places. Offshore, of course, they're very, very much used because they're lightweight and they're small in size. They're usually the same size as the pipeline, so they don't take up much space. They're also easily proved offshore, whether it's coming from a separator, measuring oil and water runoff of a separator throughout the production of the rig, and then finally for the custody transfer from the offshore or ship to the pipeline. These meters are installed in banks, calibrated and used as a custody transfer as the physical measurement from well to pipeline. Further down the road, of course, into the refineries, whether you're measuring chemicals or simply oil, hydrocarbons into the refinery. These meters provide accurate delivery and offloading systems. They're used within the refinery to storage facilities for measurement, for mixing and blending, and again, so offloading and inloading to the refinery. And of course, transportation, as we put this oil onto ships, off of ships, into tankers, into trucks, these meters can be used directly directly measure any fiscal or any transactions between the ship, the truck, and the pipeline supplier or refinery. And then finally, to your distribution, where we can get it into your storage tanks, get it into your airplanes, get it into airports, truck loading, anywhere else that comes mainly directly to you, the end user. So a full range, and these meters being available in the sizes and flow rates they are, can certainly provide services and functionality to all your metering equipment. So here's some pictures of some of the places you may have seen turbine meters, and you may use them or think about using them. In the truck loading, like I said, this little 1200 meter is usually available in 3 and 4 inch sizes, and it can fit directly into the tank loading system to the truck, usually with a little preset, and easily ramps up and ramps down effectively and efficiently to give you accurate measurement. And the tank farms and storage, whether you're coming in from a pipeline, which is the picture next to it, coming into the tank or offloading onto a ship, you can use the larger turbine meters, and again, accurate and reliable. And I think that's what people like about them. They know how they work. They're very simple meters. They know how they work, and they can use them throughout their facilities. And having knowledge about them, they know how to maintain them, know how to take care of them. So loading arms, again, onto your ships around FPSOs. You see them everywhere on these facilities. And finally, the pipelines, but sometimes they're in very large sizes, or sometimes they're in skids with multiple runs, giving you a variety of, or a variability in rangeability, from very low to very high range on a single skid. So when we use a turbine meter, we think that they're the only meter out there. Well, they're not. And we know this. So we compete with some other technologies out there, and one meter doesn't do it all. You know, we'd like to say that it does, but it doesn't. So the turbine meter has its place, and it fits into a nice niche of, but a large niche of possibilities that compares with a mass type meter, a Coriolis meter, and it also competes with a PD type meter, which has been around for a very long time. So when you're installing your metering system, you know, you've got to think about what kind of things are you looking for. Do you have space? Do you have land available? Do you have weight restrictions? What kind of things are limiting you? Are you able to prove the meter? Do you have to take it off? Do you have to maintain it? All these things come into play. So I simply compared a flow range of 1200 to 12,000 barrels per hour. And you can see here that on a 10-inch turbine meter, you would need a 16-inch PD meter. So what would that do to your weight? You know, you go from 217 pounds pipeline size meter to 8,500 pounds on a PD type meter. These might be limitations for you. Size may be a limiting. You know, you do have upstream lengths with the turbine meter. You may not have that with a mass meter, but you do have physical space limitations with your mass meter. Most of them can be used for master meter systems, so they're accurate enough to do that. A lot of people use the turbine meter to prove or calibrate the Coriolis meter and the PD meter, and sometimes it goes the other way. So it depends on that. Very easy to prove turbine meter is because it gives you the high resolution pulse output. Manufactured pulses are typical on a Coriolis meter, but both the PD and the turbine meter do give a physical pulse output. For maintenance, there is only one moving part in the turbine meter. It sits on bearings, it's a rotating rotor. So if you keep the line clean and you reduce air or gas in your liquid lines, then you're not going to have any problem with the meter, but it can be replaced. The whole set of internals can be replaced. The rotor can simply be replaced. It can be calibrated and reinstalled online. Most offshore capabilities either have a proving loop or they have spare parts that they just simply take out and put a new meter in. The mass meter, as you probably know, doesn't have many moving parts either, but it does have internal sensors that can break. Again, the whole meter has to be taken out and sent back. On PD meters, as many of you may know, there are multiple parts, whether it's bearings or sliding blades, just multiple parts that need to be replaced, seals and everything else on PD type meters. So that the turbine meter does offer a simplicity and also an ease of maintenance in your applications. So there's two types of turbine meter out there, and you may have seen them or used them, in fact. We have a straight blade design, which is the Daniel design, and we have a helical design, which is 2 or 3 other manufacturers provide this. So both types of design work on the same principle, where the rotor spins at a velocity and the diameter of the pipe determines that velocity going through the meter. So in the Daniel meter, the straight blade design and the helical design, we have a light rotor and we have a standard rotor. The lightweight rotor obviously used for your light hydrocarbons, less driving force, less momentum. And then we also have a standard design, which is typically this rim type rotor, which is heavier and much more capable of withstanding heavier fluids, but it does limit some of the low ends. So you have to look at your rangeability for that. Both meters offer lower pressure drop when compared to other designs. The helical meter perhaps a little bit less, but nevertheless, in the overall scheme of things, the piping systems, the turbine meter has a relatively low pressure drop. The Daniel turbine meter does offer dual pickups in a single enclosure, so that just allows for ease of maintenance, ease of access. You don't have to have 2 different sets of electronics coming. Everything's installed in this enclosure. The Daniel meter also offers a Teflon coated rotor. So if you have particularly dirty or fluids that can provide buildup, wax and stuff on meters, then a Teflon coated rotor is available from the Daniel arsenal of meters. In terms of multi-viscosity, the PT, the 1500 type meter, I keep calling it PT because I go back that far, but anyway, the 1500 type meter does work on high viscosities. It does not, however, perform well across a range of multiple viscosities, and that's where your helical rotor is probably a better option for you. The 1500 does offer, though, a high resolution output, which the helical meter does not. So you do have to use some API calculations for proving and to get your 10,000 pulses out. So, excuse me, it's hot in here. Bright lights, big city. Anyway, so the helical meter also offers a removable cartridge for maintenance. So you can simply take out the cartridge, send it back, get it recalibrated. The Daniel meter does not have the cartridge system, but it does, you can replace it with a new set of internals or indeed a calibrated rotor. So those options are available, and both meters can provide premium linearity, which we said was 0.15, or in reduced rangeability, it can offer 0.07%, depending on your accuracy requirements and your rangeability. So we do calibrate every meter that leaves our facility. We have a facility in Chihuahua that allows us to calibrate on mineral spirits on 1 sizes through 8-inch. So we can cover a full range up to an 8-inch. We can offer external labs if you require calibration on flowing fluids. We have relationships with many facilities in the world, in fact, that have calibrated our meters over the years. But for a standard calibration straight from our facility, we can offer 1-inch through 8-inch over a full range. We offer repeatability plus or minus 0.02%. We can do a 10-to-1 turn down, and we can give you these optimal 0.15% uncertainties in this facility. On the larger sizes, we use a lab in Utah that is calibrated on water. It's 10-inch through 16-inch sizes. So depending on your requirement, depending on the uncertainty requirements you have, we do have the capability to provide you meters directly from our factory or through our relationships with other labs, get you the accuracy and the measurement uncertainty that you need. So we do have representation all over the country in the US. Our national sales director, our North America sales director is John Vandelar. And as you can see from this chart, we do have coverage all over the country. Please reach out to any one of these representatives if you do require further information. If you do require, you just want to talk about your application or your installation, reach out to John. You see his email there. If you need direct contact, and he can put you in touch with either myself or your local representative if you need someone local to talk to. We also have representation in Canada, so 2 different Spartan, Trillium representation in Canada, again, if you need to reach out to anyone local. Around the world, we have our international sales directors. In Latin America, we have Ruben Izara. In Europe and the Middle East, we have Mark Dutton. And in Asia, we have Edwin Kwok. So any one of these gentlemen would be happy to support your questions, pass on information, and provide you information you need. Of course, you can always go to our website and get the information there at www.daniel.com. So there you are. So typical customer questions, what are our lead times? So standard meters, straight out the catalog, 6 to 9 weeks. We have spare parts sitting on the shelf, so we can usually deliver them in 3 to 7 business days. Anything special, any special materials or maybe non-standard ANSI ratings would take probably 1 to 3 weeks to process. Now, any technical support you may need, you can contact us directly, Monday through Friday, or again, in your local time frame, call your representative up there or call the sales director. You'll have access to any one of those. We do have some spare parts on some of our legacy products, mainly things like coils or preamplifiers, but depends what you need. We may have some parts in stock, very low on mechanical type parts, but definitely on the coils and preamps, we can probably support you there. So in addition to our turbine meters, of course, Daniel offers the control valves in liquid and also our full range of differential products, including the senior, junior, simplex fittings, OFUs, plates. We can certainly support your needs in both liquid and gas applications. So thank you very much.
Thank you so much, Angela. That was wonderful. And I see we do have a few questions.
Oh, good.
So the first question is, why was the original Tursite bearing discontinued in the former LR meter?
Okay, so we went to the aluminum. I'm not sure, to be honest, I'm not sure why the Tursite was, unless application-wise, it was becoming, the applications were becoming more difficult. So perhaps we went into the more ball-bearing steel race design. Now, I think that's what you mean. I'm really not, I kind of left during that time frame, but I understand that we did have the Tursite bearing. I can only imagine that it was a ruggedness and design that helped us move. And also, of course, we incorporated a lot of knowledge with Brooks. So we took the Brooks design and the Daniel design and combined, and I believe this is the 1200 series was a result of that. That's what I think possibly happened.
Great, thank you. And another question I have here is, usually small turbines should be calibrated with a specific kinematic viscosity of the fluid that it'll work with. Are your turbines calibrated to the specific properties of the fluid? How do you assure the performance of the turbine if the pipe handles different types of fluids?
So like I said, our facility in Chihuahua does calibrate on mineral fluids. If you do require it to be calibrated in your own product, we would use a third-party calibration facility and have it calibrated and at your flowing conditions across the full range of your requirements. So it's not something we have done internally, but we have the relationships with third-party labs to do that.
Perfect, thank you. And another question, how much is the maximum cable length for pulse transmission from turbine meter Daniel to a flow computer?
I think we say 6,000 feet. Is that right? Sounds like a lot, but I think it's 6,000 feet. And we do have that information stated in our brochure, so you can check me up on that and correct me if I'm wrong, but I believe it's 6,000 feet. Anything beyond that, then yeah, you need to stage it, whether it's a marshalling panel or something else to make that work.
And then one more question. I've seen 2 wire outputs from other preamps. Any plans to implement this in the future?
No. No, we don't plan on doing that. We like the independent pulse line, independent from your power lines. So that's why we do what we do there, and it works very well. These designs have been tried and tested for many years and work very well. So we have no intention of doing that.
All right, I don't see any more questions. I am going to send the survey link. If you would like a copy of this presentation, please fill out our survey. It will help us to continue putting out further webinars in the future, and your feedback is greatly valued and appreciated. Also, once you complete the survey, we do have 5 mystery prizes that we will be giving away. So once you complete it, you'll be entered to win, so to be one of the lucky 5. If there's any questions at all, you have Angela's email address, and thank you so much for attending.
Thank you. Thank you very much. Bye-bye.